chapter 3 of our UAS3 tutorial, where we talk about how to properly use UAS3 and get the most benefit out of it. So let's just take a look at what we have done until now. We have created a nice tree structure. We have created some alarms and attached them to certain positions. We created several work orders. So more or less we did an excellent job until now. So now it's time for us to collect some data. So in order to collect data, and we'll show you how to do it, although this is not a free 40 video tutorial, we'll play just a little bit. So you can see here we'll be using two different simulators and the instrument. I hope you can see them well. Here on this screen you can see a little bit bigger what UAS3 is doing. I'll just try to make it a little bit bigger. Yes, this will probably help you to see better. And here in behind we have a Rhapsody box software, so I'll be simulating some signals to collect something that we can show later how to work with it in UAS3. So what I will do right now is I will go to my surveys. So if you remember, we have pump inspections, backups only, grease lubricated backups, cavitation check, and urgent. So let's start with something simple. So water circulation, pump group 1, pump 1, motor, non-drive end bearing, vertical lubrication with grease. This is just an explanation. There will be some noise because this needs to work, of course. So let's continue from here. I can collect temperature. And that's it. It's saved. Then I will collect our first vibration data, 10 Hz to 1 kHz. As you can see, it's predefined, everything as we predefined in UAS3. So I'll collect data. We'll do this part fast so I can show you how to work in UAS3 later. Okay, I will save the data. Good, I will move to next point, 10 Hz to 10 kHz. Fine. Collecting data. Good. Okay, now let's move to horizontal. Okay, here we have RS2T. Good. Now let's make some noise there. So I started one of the bearings in our Rhapsody box. Not really great one, but that's the point of the inspection. So we are collecting more data. Excellent. Save the data. Okay, we can say that now we change to horizontal. We'll not necessarily do it, just to collect some data so we can compare it. Save, move to next one, and collect data. Okay, now let's move to non-drive end bearing axial. Again, we will just play a little bit. I will not change the position of the sensor at this time. Good. And also 10 Hz to 1 kHz. Okay. Save. Okay, now I'll go back because I want to collect more data on one point so we can show you the trend. So what we will do now is change the speed a little bit, just to make it a little bit spicy, so it will be slightly different. Let's collect temperature again. Now we can make some fun and make it slightly warmer. Let's collect again vibration data. Fine. Again, this, as you can see, when you're following your survey plan and your work order, it's going pretty fast. You don't have to do any settings. As a matter of fact, when you're in a survey mode, you're not supposed to do any settings, and you cannot do them because they are predefined. Okay, we collected this. Let's do a horizontal part. Okay, RS2T. Increase the amplification slightly. Down. Okay, and let's do the measurement. Excellent. Let's collect more of this. Fine. And this as well. Good. Okay, now we go back to non-drive and bearing axial. Okay, just to make it slightly different, I will change the speed. And the last one. We'll keep our activities on non-drive end bearing for the moment and collect several data sets on this one. So we have something in our UAS3 so we can play with. Okay. Good. Okay, now I want to do another thing. So I will escape out now. I'll go directly to sensor settings. And sensor settings are, let me increase the amplification a little bit. Okay. Sensor settings on this one is predefined in a work order, but if I go to free mode, I can do something about it. So I will change the settings and I will say, no, I don't want 5 seconds. Let's say this is some specific occasion and I notice some problems in process. I see the variation because of the load or whatever. So I want to make a little bit longer measurement. Fine, I will do it in free mode and I will take my measurement now. This measurement will be 15 seconds, of course. And once the measurement is done, and that's going to be soon, in the meantime we can shut down this noisy guy. Okay, measurement is done and I obviously want to save it somewhere. So when I click save, I need to say where. Because I was not working through survey mode or work order mode, I was working in a free mode where I can do whatever I want. So now I have to say where do I want to save it. So I want to save it in exactly the place where we were doing all our measurements. And it's saved. Good. Now we have a certain amount of data, not too much, just enough to play a little bit. So just one more thing, maybe we can make something that we can call cavitation measurement. Why not? Because we have some alarms there, so let's see how does that look like. So pump inspection, water recirculation, pump 1. Let's go to the pump, and now we will go to volute. Okay, fine, and take the measurement. Okay, if you remember, we set this one slightly longer. And save the measurement. Now you may be confused a little bit with the difference, because I went back to survey mode, as you can see here on the screen, and I was working in a work order, so that means I was using predefined settings, and of course the instrument knows exactly where it needs to be saved. Before the measurement before this one, I was working in a free mode, so I can do whatever I want, and the instrument asked me where do you want to save it. So that's the difference, just to avoid any confusion. So what I will do now is go back here with our software, with our UAS3. Now let's pretend we came back from the field, we have all data collected, and let's download from 340 to PC. So device is ready, transfer. Now all the data we collected will be downloaded to UAS3 and set in exact positions where they need to be, as we predefined before. So considering that we were doing everything in 256 kilosamples, it's not going at a lightning speed, of course, but it's still very fast. Inserting data, and 18 measurements. There we are. Okay, now you can immediately see certain change. So alarms are activated where they need to be activated. So you can see out of, if I click on water recirculation, out of 198 points, I have 2 points in alarm. So let's first see them. So if I click here, it says on the non-drive end bearing horizontal, your acceleration, your vibration 10 Hz to 1 kHz is in alarm, and my next alarm is on the pump, on the volute. So this way I can rapidly jump to the points where I obviously have a problem and there is a certain significant change. So for that you will use this tool. It's quite practical and quite convenient. So let's take a look at the data a little bit. So motor, non-drive end bearing vertical. You can see temperature first. Let me just go back. If you click here at the measurement point, not the measurement setting, the sensor level, but on the measurement point, which is here, non-drive end bearing vertical, you can see that we have 3 different settings inside. We have temperature, we have vibration 10 to 1 and 10 to 10, and here are the overall numbers of the last measurement. So you can see acceleration, green means there is alarm, and alarm is fine. This one as well, black font means there was no alarm attached. So let's go inside a little bit. So we click on the sensor level. We had 2 different temperature measurement. The first one was just measuring the air. It's not that cold in this room. And then I put my hand in front of the instrument, and it was of course slightly higher. So you can see the trend is automatically generated. Then I go to vibration, 10 Hz to 10 kilohertz. What you can see here is that our first measurement was, you can see the data here in matrix, but you can also see it down here. So My RMS acceleration was 0.15. Green font means alarm attached, not activated. So condition okay according to alarm. But the peak was 0.3 G, which activated obviously some alarm. And if you remember which alarm, that will be safe alarm. So this one, alarm attached and activated in red, in danger. Black font means no alarm assigned at all. But our next measurement was better according to alarms. As you can see, the two indicators monitored by our alarm are green. So at this point, everything is okay. I will explain you later how we will work in a graph pen with all this data. Then we go to 10 Hz to 10 kHz. Again, you can see we have data here, so we have 2 of them. Otherwise, if we have more, the matrix will show you last 4 measurements. We have no alarm attached. Everything is black here. We'll play again, I say, with all the graphs a little bit later. Then let's close this one. Let's go to non-drive end bearing horizontal. We collected ultrasound data, RS2T. We have 3 measurements. So the all font are black, so we have no alarm attached at all. But I did something on purpose to show you a difference. To show you something that you will notice immediately, that the last measurement we did is highlighted. So there is a very simple reason for that. You can see that this measurement is, the first one is 5 seconds. The second one is 5 seconds. Let's check the settings on this point. What is the acquisition time? 5 seconds. So those two measurements are according to settings, but this one is not. This one is 15 seconds. So when you have a graph, when you have a static trend graph, you should always compare the data with same acquisition time. There can be a difference between 5 seconds measurement time and 25 seconds measurement time. So you sometimes want to exclude this point from your graph. There is obviously a reason why we took it. So as I said during the taking measurement, I can say there are some changing in process and I want a longer measurement to see how my machine behaves with the change of load. Fine, you can do it and you should do it. So if you want to avoid settings you did in UAS3, just go to free mode, do whatever you want and save it in the same position. But UAS3 will mark this measurement, it will be highlighted like this one, as a measurement with a different acquisition time from the one in settings. And in settings we have 5 seconds. So this is a warning for you. And you can see it's this one, the last one in graph, the newest one. What you can do with that reading measurement or any other, you can exclude it from the static trend graph. So I can say, let's imagine a situation. I can say, okay, I got what I want. I understand the data now. I understand the changes with change load, but I don't want this to pollute my graph. I don't want to compare it with all my other measurements, so I will just exclude it out from the graph. And you can see now we have only first 2 measurements. This one is now in italic font and cross-through. Of course, I can click on it and I can include it back. So this is a very interesting feature that will help you, especially if you sometimes work in free mode and sometimes in survey mode. If you for some reason change your acquisition time, you can do that. So let me repeat. We don't have any alarms here, so everything is in black font. Static trend graph is automatically generated. Our spectrum and time waveform are populated. Let's see what else we did. We collected also in horizontal direction. We collected 2 sets of data. Here we have red alarm, and that one was shown to us when we clicked here. Static trend is populated, time waveform, spectrum, everything is here. Then we can move to non-drive end bearing. Same situation, data collected, they are shown historically. So on the top you have the newest one, on the lower end you have the oldest one, of course, same in matrix, same in here, so this is as a function of time. And now let's go to volute. This is another one we collected. I can click here and I will see all my data. So you can see the alarm is triggered because of peak. We have set the alarms on peak and crest factor. Crest factor green font sent me alarm is there, but it's all fine. Peak, alarm is there and it's activated. Triggered. You can see here my measurement is here. I have only one, so my static trend graph is actually point. I have my time waveform, my spectrum, so everything is here. Good. So this is the first step when you want to get familiar on how the data is displayed in UAS3. So we downloaded the data at all the points where we have alarms. They are shown. If there is nothing, that means that alarm is not assigned or no data is collected up to this point on this measurement point. So now we collected some data. We have alarms displayed in some places not. And let's jump a little bit deeper now. So as I told you, when we click on the measurement position, measurement point, we have all three sensors, in this case three, it can be more of course, shown here, but for the moment I want to see ultrasound. So the ultrasound measurement, now let's go from the matrix first and we'll move step by step. The matrix shows me three measurements from newest to oldest, and they're all displayed here. Font also says, is it in alarm or is alarm attached at all? Also, what I can do from here, and this is the tool as well, you can see that in static trend graph, and we will do it now in parallel, static trend graph shows you peak, max RMS and RMS. Crest factor is not shown. Click, let's show it. So by clicking on the indicator here, you can control what is being displayed right now in your static trend graph. If I want to see just crest factor, I will just remove other three indicators from the static trend graph, and right now, as you can see, I see only crest factor. So just remember that this is a tool to decide what will be visible and what will not be visible here. By default, the visible is what we defined in our graph and static trend settings. This is defined. You can see show me RMS, max RMS, peak, but don't show me crest factor. So it's following that rule. But still, it doesn't matter what defaults are. You can control it from here and say I want to see some more, or I want to remove something. I'm not interested about it right now. Let's move to static trend graph right now. So what you can see here is the trend of our three measurements, because we have only three. We see here what is shown. So the round icon is RMS, triangle is max RMS, and the square is peak. There is a scale for each of them here, and remember from the beginning I told you we set the scale to auto. So we didn't define what will be the maximum, so we say just set it on auto. And this is why they are all somewhere close to each other. So they are in the same level, because you can see here the peak is 64 here, and in this case particularly it's 60, and this is somewhere around 43.5. If we set up the scale differently, it will be shown depending on the scale we define. What I can also do here, I can say include data labels. So I'll go back, right click in the graph, include data labels. So now each point has a data label, the time and the value. I can also say mark data points, they are already marked here, and I can also maximize. You cannot see it right here because I'm on two screens. So you will see it when you click just maximize, it will be your static trend graph full screen. Now let's go back here, and first let's do something nice and again repeat how you will define your graph. I showed you before, if you go to options, graph and static trend settings, here is your menu to set up all your graphs and to set up what will be displayed and what not. So if I go to static trend, I will define what I just defined and all other things. But for instance here I can say, yeah, that's a good idea, but I'm not sure that this looks quite well because it's everything is black. So let's change RMS to Firebrick. Let's show peak in some kind of maybe dark cyan. RMS show me in gray, and why not showing crest factor in blue. Fine, so we define all this now. While we are on it, we will say, okay, show me crest factor as well, show me everything, and I can say that I want my desk background to be maroon, label and text to be white, event color to be whatever color you want. Just do something so it will be interesting. Graph background, let's, I don't know, seashell, and graph foreground, let's do it maroon. So let's see what we did. Save and close. So this is your graph. You can see I did it from this menu, but there is another way. I can also do it from here. If I double click on this graph, you can see the menu is not now open, but I can do only this one. I cannot change others. So something what I will do now definitely is I will change graph foreground, and it looks quite well. Nothing revolutionary, but it's not bad. So apply settings and save and close. You can do the same thing with all other graphs. So you can set them in graph and static trend settings, or you can do it directly in the graph. So click here, change everything any way you want it, save and close. It will apply to entire tree structure. Same with your spectrum as well. So I explained you what you can see here. From the bottom pane, you can exclude certain measurements, any of them. In this case, the highlighted measurement is because of the longer acquisition time, but it doesn't stop you to exclude any other measurement if you see that maybe that measurement was not really properly taken and there might be some problem. You can simply exclude it. It doesn't mean it will be deleted. It will still be there. You can include it later. So this is, we explained you matrix, I explained you the static trend graph. Now let's see some tools in time waveform. So by clicking here on each measurement, if I click on the oldest one, there is a time waveform of oldest one, and the scale is automatically set. So your graph, your juice will be in the middle. If I click to the next one, you can see this one was taken 3 minutes later, and then I can click on the last one, and that one was taken again 3 minutes later. So let's open this one. Now you have your time waveform. What you can do is, first of all, directly from this menu, you can play it. You can play audio. So if you want to connect the sound and visual appearance of the signal, but then you can enlarge your time waveform by clicking here. So enlarge it, and now you can work with it. So let's start from the right. First, what you see here are indicators. Indicators concerning this signal. So for this particular signal, we have RMS 42.88, max RMS 43.03, peak 59.12, and we have crest factor 6.48. So this is information in this box. In next box, you have the information about highest peaks, 10 highest peaks. So I can choose treat all values or treat only positive values. So if I say treat all values, it will show me that my highest peak happened in time at 4.836 seconds. So it's somewhere here, as you can see. The next one is that one, and this is the value. So you have time, this is time waveform, so it's the energy against the time, amplitude against the time. So you have both information here. We still not have any cursors here, so these three boxes are empty, but we will populate them quite soon when we put some cursors here. What you can do in the graph itself, before we touch the tools, is that by scrolling the mouse wheel front and back, you can zoom in signal. So you can zoom it in respect to position of your mouse. You can see here, and if I move my mouse here, I will be zooming in this part. So you can zoom out again with your wheel, or you can right click in and say unzoom. So we unzoom the signal. So you know now how to zoom and unzoom the signal with the wheel, but there's another way as well. You can click here, your left click, open the section you want to see, select it, and release the mouse, and now it's zoomed exactly there. On top of that, you can move it here. You can move the timeline here and see the zoomed part on each position in the signal, and of course you can use your mouse wheel here as well to zoom it in, or you can simply drag and drop this border of the zoom part and control your zoom of the signal. So it's quite convenient. You can do it in many different ways. The next thing you can do within the graph, if you right click in the graph, you can say include data labels. Now it will become very busy, because now we include data labels for each measurement point. It's very busy because, don't forget, we took 256,000 samples per second, 5 seconds. That's a lot of data. So there is a better way to show you that. If we zoom the signal in and then we zoom it a little bit more in and even more in, now I can say mark data points. So each sample of these 256,000 samples per second will be now marked. If we zoom in a little bit more, you can see here is each sample we took is now marked. Now if you put show me data labels, now it makes more sense, because now you have time and amplitude. Of course, when you zoom out, it doesn't make much sense, because it's just very busy. So to repeat from here, you can include data labels, mark data points, undo zoom. You can maximize full screen this section. Let me just do this. Okay, it's clean again. And you can export it for your report. So you can export it as EMF, WMF, BMP, JPG, or PNG. You can set up your width and export it as a picture for the purpose of reporting, but you can also export text/data. So that means that each data point, each value will be exported. So if you want to analyze it in some other way, go ahead, you have that opportunity. Just be prepared to wait a little bit when you want to export a really heavy piece of data. Now when we did all this, let's see what we have with tools up here. Again, let's start from the right side. This is 256 kilosamples. So everything is shown right now because fast preview is unclicked. I can click fast preview, and this is now much lighter. This is downsampled to 32 kilosamples per second. So if you look at this small section right now, it's downsampled. So if you want to scroll through your results just fast preview is more than enough. But if you change it, this is how it looks. This is the whole, all of the data you have for this point. So when analyzing, I definitely suggest to uncheck fast preview. When you just want to scroll through a bunch of data in your history, it's quite okay if you click fast preview, and then it will happen really, really rapidly. So I can unzoom it here, and now let's move on. The arrow sends me back, so it will minimize and show me the whole work area. I can play the signal here as well, so I'm sure you can hear it from my mic. I can stop play with this button. I can export the data. Considering that this is 250 kilosamples, you can export the data, but you can also export the audio file. So you have two options. If you want to export the data and analyze it in some other software, just go ahead, click here and export the data. If you want to export audio, it will be export as a WAV file, heterodyne, so you can listen to it in any player. The next command here is show me heterodyne ultrasound spectrum. So if I click here, it takes me directly to spectrum. Just let me remind you, spectrum is here. So I'm now in a time waveform. This takes me directly to spectrum, or now back to time domain. So if I want to play a little bit and compare what about this repetitive pattern here that it's definitely repeating, I want to see how does that look like in the spectrum. I can use this shortcut, or I can go back. The next one is add single cursor. Single cursor is practically a comment. So I can when I click here, I will do it again so you can see it. When I click on this tool, the comment will open, and I will say here interesting point. Interesting P, or just interesting, and I will say okay, now where do you want to put it? Here. So I will say this is my marker 1. This is very interesting point. It can be anything in your signal. It can be some kind of strange transient event or whatever, and you can say, this is interesting, and let me save it for my further analysis, and put any comment inside what you want. The next one is your delta cursor. Delta cursor is very useful during your analysis. Sometimes you will define one rotation in your delta cursor and then see it here, or see the delta between two events. So simply click on the tool, so select the tool and place it somewhere. Now you have D1 and D2. D1 is leader. If you move D1, as you can see, the delta time stays the same. So I move D1 and put it at a certain position. D2, if I move D2, I will change the delta T, the delta between these two. But now, don't forget, on the right side, in this box, single cursors, it says yes, you have M1, you placed it in time at 1.58 seconds. The amplitude in that point is that much. I can change it here. I can put it at 2.5 seconds. Now it's moved, you can see. Also, now it's exactly around the middle, so let's put 1.1. Again, I'm really precise, 0.9. Okay, it's there. Now my delta cursor, all the data about my delta cursor is here. So you can see my D1 is placed at 2.852 seconds with amplitude that much. My D2 is at 3.058 seconds with amplitude that much, and delta T is 0.206 seconds. Corresponding frequency, the delta frequency is 4.86 Hertz. So you can see I can change the position here of the delta cursor, and I can put it at 2.7 seconds. So you can see it will move. And I can change delta T. I can say 0.5 seconds. You see, it moved. But there is also a very practical way to use it. So you can see I have my delta cursor now placed over my repetitive pattern. So if I zoom it out a little bit, zoom it in a little bit, I can say, okay, I want to know what is the difference, time difference between these two events. So you can see the time difference is 0.036 seconds, which is corresponding to delta frequency of 27. We will find the same thing in spectrum if we go there. So I just placed my delta cursor at the position that explains for me a lot. This was done on a simulator, so the signal is really clear and everything is perfectly repeatable. So what will be my next tool that I will use right now? That's going to be my periodic cursor. So as you can see, you can combine them all in the same time. You don't need to delete one to put another one. So I can click on my periodic cursor and place it anyway. It will open up 6 cursors. Again, the same logic as before. P1 is a leader, so I move the entire set with P1. But any of them from P2 to P6 is actually changing the delta t between them. Don't forget we are in a time waveform, so we will always first think about delta t. So I can do it here. I can set my P1 on one of the impacts, and then with this one I can search the nice match. Okay, and I'm here. So I place it here. And I have P2 and all the others at the same delta t, which is 0.036 seconds, and which is corresponding to 27 Hertz. Of course, I can change the delta. I can put it to 0.05, and they will change a little bit. Just a second. Oops, sorry. Okay. So I put them here. I can change all across the signal and see if what I found is actually repeating everywhere. Yes, it is. So I'm happy. I can also change y-axis values. So if I click on this tool, right now my maximum y-axis here is 1.1289923. Another one is different. I can set it all to 1200. Right, you can see now 1200 minus 1200. So y-axis is set here. Once you go back to another signal, it will go back to automatic. So don't forget that. You will use this during your analysis if you want to set it differently. Of course, there is an eraser tool as well. And it doesn't mean it will erase part of the signal. It will just set that part of the signal to amplitude 0. So let's see how it works. I will select certain part of the signal. Okay, just let me show you something first. What you need to pay attention to. So you can see. So you can see right now my RMS is 42.88. Just try to visualize and remember these numbers. So if I move this, I select this part and say, okay, set amplitude to 0. You can see that this part is now 0. It's not gone. You cannot just cut piece of the time, but it's set to 0. Of course, my RMS has changed. So it's effective immediately. It's telling you, okay, the rest of the signal, including this part with amplitude 0, is now 41.72. It can happen sometimes that you have a good signal, you have a good data, but unfortunately you dropped your keys on the machine during the measurement. So you can actually take this small part in time, remove it out and say, okay, everything else looks fine. So all the bad numbers are coming from this mishap during my measurement. When you move away to another signal and you come back to this signal, everything is back to normal. So you cannot delete part of the signal permanently. It's there and it will not change. But for the purpose of your analysis, you can do that. So let me just put my marker back on, because I haven't shown you another command, and this is why I lost all my cursors. So I will put my D1 and D2. I will set my periodic cursors here. And my next tool is save all. So save my cursors. That means you did some analysis, you find some interesting stuff. Okay, this is what I was looking for. Let's save the cursor so I can look at it later, because I don't want to do the same analysis twice. So just save cursors in this position. So they will be saved, and when you move to another position, you come back, it will be the same, but you can also delete them. So you can click here on a drop-down menu, you can remove all cursors, or you can remove just some of them. So I can remove single cursor number 1. Everything else is here. Or I can simply remove them all. I will not remove them all for the moment. I want them to be saved. Here you can see in my periodic cursors, since I assigned them, there is all data. P1, time and amplitude, time and amplitude for P2, 3, 4, 5, and 6. There is delta T, and there is a corresponding delta F in Hertz. So you have all this data here. It's very practical to have it on hand during your analysis. When you finish what you want to do, save your cursors and report your findings, and let's hope that everybody will be happy after that. So those are the tools you have in a time waveform. Now let's go back to our spectrum. So this is a spectrum for RS2T, focus 256, for our measurement, for this one. And again, you have very similar tools, almost the same. So you have all the indicators here about this signal. You have highest peaks. You can sort them by frequency, or you can sort them by energy. It's both useful depending on the situation in the graph. So feel free to use it. From here, you can of course export audio file. You can go back to time domain, so you can jump from time to spectrum during your analysis. Same thing, you can add single cursor, whatever, and you put it somewhere. Let's say we put it here for whatever reason. Then you can use your delta cursor as well. Now, immediately your delta cursor is here. Considering that now we are in a spectrum, we are talking about delta F, delta frequency. So let's just for the practice purposes, let's put it here and see what is the delta F between these 2 points. It's 7.6 Hertz. Of course, if I unzoom, I will move to my next point and I will add periodic cursor. And I will, let's say, set it here to see if I have some harmonics. To make your job easier, you can say, okay, my highest peak here is 26.8 Hertz. Good, so I will set my P1, and you can do it from here. So you can set the position of P1 to, I'm forgetting fast, 26.8. So I will set it to 26.8, enter. Now it's completely aligned with 26.8. And I want you to set all the harmonics to 26.8. So let me see if they match. Oh, they match so nicely. So you see, through this box, it's not only the information about the cursors, it's also the control box. So you have two ways of controlling it. You can do it manually, like this, setting all the sensors, so you are investigating and looking what is this and what is that, or you can do it directly from here. It's your choice. The job of UAS3 is to offer you all the necessary tools to make your job easy, nice and comfortable. So this is what you can see in your graph pan. There are huge opportunities to play with signal and to understand it. Let's go down just a little bit to bottom pan. As I told you, you click this, you click the last measurement, you have the waveform and the spectrum of this measurement, next one and next one. So this is how you will be changing them. Again, you can use, don't forget this, you can use selection, you can filter the data, you will not have only 3 points like I have here right now, you will have much more. You can set alarms from here, as we discussed before. You can add this point to certain specific work order. So you can just imagine you find the problem and you say, something is wrong here. So just to help my technician and to remind myself, you can choose this point and add it to a work order which says extremely urgent to do it tomorrow again for that and that purposes. And of course you can set the interval. It's very often very useful, because when you want to set the interval, then you will do this. Let it just open. I will set the interval to, let's say, 10 days. So what happens if my normal interval is 1 month and I found a problem, and the problem is now, let's say, in a stage of anomaly, so something is going on. I want to monitor this asset more often. I don't want to change my interval on all assets because it's not necessary, it's all fine. Actually, sometimes I can increase that interval from 1 month to 45 days. But in this particular case, while I'm on this asset and analyzing and saying, I found something here, there is a problem, the first action should be keep on monitoring, decrease the interval, monitor more often and see how the progression looks like. So I can click on this point and say, please change this to measurement every 10 days. I'm exaggerating here a little bit, but that's how it works. For you, it's important to understand the tools and how to use them. And now on this point, the interval is set to 10 days. Let me just open it up. So I will edit, and you can see interval is changed on 10 days, only on this particular point. So you don't need to go there, you can do it directly from here when and if you find a problem. Of course, they are not always bad news. If they are very good news and everything is beautiful and stable after 6 months, then you can have a luxury of saying, okay, let's increase the interval from 1 month to 2 months because everything is really nice. So why not? Okay, so we discussed what we have in GraphPan. So let's discuss a little bit more what we can see here. Maybe I'm repeating it, but just to be sure it's understood. So the water recirculation, the whole node is under red alarm, obviously because of the pump group 1. And the pump group 1 is in alarm because of the pump 1. And the pump 1 is in alarm because both motor and pump. If I open motor, I can see that there is a non-drive end bearing horizontal and pump volute. So it's enough to have just one red point and in measurement level, and all the parent nodes will be red up to the top. Of course, you can always use this interesting tool which will bring you to the exact measurement that triggered this alarm. So let's move here again. I want to show you a little bit more what you can do in the bottom pane. Just to add event, so you can see it in this point, I can say, okay, here on this point, you cannot add event because this is the measurement level. This is not the point, it's a sensor definition. But what if you go here, you can add event. And on that event, I can say that today, 20th of April, I can say that interval shortened. Because that is exactly what I did. I shortened the interval because, and you can see it here, and that will remind me in future that I shortened the interval here to 10 days, if you remember, because I noticed some irregularities. And because of that, I shortened the interval. I can also add another event here, of course, in the measurement point. I can event inspect asset. And that can be in any kind of event, because probably later on when somebody inspects the asset, it will be a good idea to have a result noted here, or let's say eventually when the bearing is replaced, to make this mark in time saying bearing is replaced. And then probably and hopefully after that the signal will look much more different. So if I go down to the bottom pane now and I clicked here, I have readings. I also have a second tab that we discussed before. I will just repeat it right now. Alarms. You see we don't have any alarms attached to this point right now. And regarding the events, we don't have anything on the sensor level because we cannot, of course. But if I go to the measurement point level, I have these two events that I added just a minute ago. There is no alarm on this level, and from the readings we have ultrasound and two vibration readings that are within this point. So I can now click here again, and when I click on the measurement itself, so I select the measurement with left click, with right click you open a menu which says edit, mark as reference, unmark as reference, and exclude from static trend graph. So let's choose this one. If I click edit, more details will open. So the timestamp is this. RMS max, RMS peak, crest factor, so calculated static values are this. What was the amplification during the measurement? It was 40 dB microvolts. What was the filter used? 36.1 to 40.7. What was the mixer frequency? 38.8. Sensor serial number, instrument serial number, calibration of the sensor, calibration of the instrument itself. What was the sampling rate? What RPM not added, so you cannot see it right now. But all this additional information is here. You can see it. What I can do also here is I can mark it as a reference. So now this measurement will be my reference on this point. Remember why? Because if I go to alarms and I say show me new alarm, and it will be on RS2T, okay, 256, and I can call it new alarm, and I can say okay, use RMS as an indicator. I can set here 30, I don't know, 36, 42, but in a relative mode I can say yes, I want to use relative mode and go for the reference value. And this is where I will use this reference value, because you can see here I just set it. I will not make this alarm right now, so I will just go out. But I want you to know why is this reference value set. It does not necessarily need to be the first measurement you took on this asset, and because that's not necessarily the best one. It doesn't necessarily need to be the measurement when the asset was new. You will just, based on your data and your analysis, which is not the purpose of this tutorial, you will choose the measurement which you will choose as a reference. So this is my asset performing at its best. So I will use that as a reference, and then my relative alarm will monitor the change in signal based compared to that reference point. Also, you can select it. You can unmark as reference, which I just did, and you can, of course, as I explained before, exclude from static trend graph. So now it's not there anymore, and you can see it's cross through and it's italic. I can select it and I can include it back into the static trend graph. There's a lot of things you can do here in this area. So from this point on, you can attach with new alarm. So let's just make some new alarm, and I can say okay, monitor RMS please. I'll put just some low values so we are sure it will be triggered, 32, and I will say save. So now attached alarm to this point, as you can see, it's immediately effective. The point is red, the RMS is red on all three, so it says yes, you have attached alarm on RMS and it's triggered at the danger level. Now what I can do next here is to use this toolbox. We mostly use it already, so you can see it, but there's one point I didn't explain until now. So I can click on my entire tree structure. showing all my measurements here in water recirculation, and I can say show me the points in alarm. And I can say show me both alert, warning and danger. Show me everything. Search. You see, I have 3 points in alarm, everything else is green. Unfortunately, all 3 of them are danger. You can select here what you want to see. Maybe you will not react immediately on alert level or warning level, but you want to react immediately on danger level. Here I checked show me all 3, and I have 3 points. So I can select them, one of them, any one of them. I can use control button and choose some of them, or I can choose shift and choose all of them and saying report them. Show me the report. Let me just drag it from another screen here. So this is my report of the fired alarms. So you have 3 alarms, and those are obviously 3 points that we have to pay attention right now and immediately. But you can do another thing as well. I can say, okay, so what is my next action? Next action is to collect more data, inspect asset. So we collected data, this is in alarm, and I can say, guys, we need to do it tomorrow again just to see what's going on, what's happening, maybe with some different settings, maybe longer acquisition time, maybe we measure more points, but I can take these 3 points and add to new survey. And I can say it critical, urgent, and save it. So I can do it from this menu as well, where I see what is in danger alarm or any other alarm, because it's obviously very important. So I want to do some action is required. Let's see work orders, and here it is, critical, urgent, exactly those 3 points. So I can manage my work from many different positions and they all need to be conditional. So there is a change of condition, there is a reason to do something, and then I can send it to my work order and do something about it. Of course, alarms, selection, we discussed already filter. We want to discuss parameters as well. I mentioned it before, I will just mention it again. You can choose what you want to see, all measurements, most recent 1, 2, 3 or 20 measurements, measurement in a certain date range, or since certain event. As you can see, now I have 4 events. I can choose one of them. Then I can choose what do I want to see in certain columns. So when I open the measurement, I want my bottom pen to show me this, not everything. I want my bottom pen to show me RPM, for RPM measurement, show me this. For temperature, show me this, and for vibration, of course, show me something else. So I can define it differently, and it will be effective immediately. So this is what you can do from the parameters. Work order surveys we already discussed. You can choose the measurement position here and create a new work order, or you can change the interval for each of them or group. So I can select a group, change interval, or maybe directly when I'm doing my analysis and I see something wrong, I can change the interval to shorter or hopefully to longer. This box is already nicely explained. So right now you have quite a lot of information. You know most of the functionalities. There is some more left, of course, and we will do it in chapter 4. Thank you for your attention, and practice, practice, practice.